All right, we are live on Tuesday, September 27th. Thank you for tuning in to the serverless panel. Today, we're going to be talking about serverless machine learning and data ingestion architectures. We're joined by a fantastic panel of people. I think this might be the most people we've ever had on a single panel, so this should be very interesting to hear all the different perspectives across the industry, across geolocations. We're actually located all across the world right now, which is fantastic. So with that, let me actually kick it off to the panelists to give everybody a chance to introduce themselves, talk about what you do currently, and anything else that you kind of want to shout out. So to start that off, let me toss it over to Paul Chin Jr. here, and we can go from there.
Hello, everybody. Paul Chin Jr. here. I do serverless development at Serverless Guru. Really excited today about this whole machine learning panel. It's just so great to see everybody here because there's a lot of things to mull over. So thanks.
Oh, awesome. And with that, Ro, do you want to give an intro?
Yeah. Hey, my name is Rosius Ndimofor. I am an AWS serverless hero and also a serverless developer at Serverless Guru, and I blog intensively. I'm really happy to be here, and let's have a great chat. Thanks.
Awesome. Luca, you are a special guest today outside the Serverless Guru family. Do you want to give a background?
Yeah. Hello, I'm Luca Bianchi. I'm from Italy. I'm an AWS serverless hero and CTO at New Experience. I work on the sweet spot between serverless and AI, and I have this cool T-shirt about serverless.
Yeah, that's awesome. That's so cool. All right, with that, Benoît.
Yeah, hi everybody. I'm Benoît, serverless developer at Serverless Guru, also a AWS community builder. Really looking forward to this panel today. AI is something really interesting. Machine learning is not something I know a lot about, but hopefully I will learn a lot today as well with this wonderful panel. And yeah, looking forward to it.
Perfect. Last but surely not least, Mr. Cyril, do you want to give a background?
Yeah. Hi, I'm Cyril. So I'm an AWS machine learning hero, and I'm currently a developer here at Serverless Guru. I feel I'm surrounded by serverless experts here, so I'm really excited to share with you, and let's see how it goes. It'll really be an interesting chat for me and for my machine learning friends. Yeah.
Cool. Awesome. Yeah, it's great to have you on for the first panel. My name is Ryan Jones. I'm going to be the DJ for the evening, afternoon, morning, depending on where you're located in the world. Yeah, with that, we can go ahead and jump straight in. I'm going to leave most of the talking to the panelists. I know I always say that, but it doesn't always happen. But for topic number one, today we're going to be talking about serverless machine learning for developers. So what does this mean? We're on serverless, we're building stuff, but we're building machine learning workloads. And what does that last piece mean for developers? Like what's going on with this topic? So on that front, let me actually hand it over to our special guest today, Luca. What are your thoughts on serverless machine learning for developers?
Yeah, I think that there is it's the right time to start approaching machine learning, especially if you are a developer, because there are a number of services that allow you to start with ease, so they can lower the learning curve. Just let me give you an example. If you want to start with computer vision, just a couple of years ago, it was pretty difficult because you had to learn a lot of stuff related to CNN, neural networks, autograds, and so on and so forth. Right now, you can start doing computer vision without knowing anything about that. So you can start benefiting from the results of computer vision and AI in general, thanks to a number of already available managed services. And moreover, you can start approaching AI just trying to deploy machine learning. So the first step can be just stick with an API, learn how to use that API. Then the second step could be, okay, I've learned how that API works. Now let me try to train my own model. And let me start with an already available model. And then the third step could be, okay, let me start tampering with the model and changing things. And then finally, you can land to machine learning. So you can reverse the learning curve. You don't have to start from statistics, then maths, then all the stuff that the user needs to learn machine learning. You can start from doing machine learning.
Yeah, I love this that you pointed this out, because I think it's totally true in the terms of the difficulty. Like I know one service from AWS is AWS Recognition that allows you to quickly jump in. I know that Google has those same services, Azure, and everybody else has similar services that provide an easy to use API. It gives you an API key, you work it into your code, you send the image or whatever you're receiving from that user over to that API from whatever cloud provider. They give you back a list of labels and results. And then from there, you can do all sorts of cool stuff inside the app with it. And that's already accessible, and you can do all sorts of stuff. I think Google has something where you could actually, they had the dolphins labeled or something. So even just a picture of a dolphin in the ocean, they had it labeled, and they could actually tell which one was which based on people just taking photos off a boat, which is pretty cool. And then also the idea that you can move through this sort of, three-step process of getting all the way to creating your own models. And I know that would probably be the advice that you'd probably give to people is, maybe don't start making your own model up front, maybe save that until you can see, does this sort of check the box initially before adding additional complexity and more self-managed stuff, which is also, kind of plays into the whole serverless thing. That's sort of what we do as well. Start serverless first, and then if it breaks down, then evaluate containers or virtual machines and so on. To continue this topic, Cyril, what are your thoughts on serverless machine learning for developers?
Yeah, it's a very good question, because I remember my first time I had to put up an application on Heroku. I mean, I thought I had learned the world, mathematics, statistics, machine learning. I had done all of that. Then now it was time to deploy. So a customer said, okay, I need this. I need you to
Oh, I'm not sure. I think my connection may have dropped. Oh, I think, okay,
sorry.
Okay,
You get
just take
me?
your back. Yeah,
Yes.
keep going. You're good.
You lost, yeah. So so with this now, with serverless, that means you're not thinking about all the server, all the capacity, all the provisioning you have to do, middlewares and all that. You just simply just go on after you finish that headache of cleaning your feature engineering, collecting data, running your iterations. You can just simply go online and you're deploying your model right immediately. So I think serverless machine learning is really a good way and a good thing for us developers on the machine learning side, and also on maybe the full stack side if you want to add your machine, some intelligence into your apps without going through all that long process before.
Awesome. Yeah, and it looks like you're coming through clear as well again, so that's great. So we should be all set for the rest of the panel too. But if anything obviously does happen, anybody that drops off, we will add them back into the stream. Switching it over to Ro, Benoît, Paul, y'all been working in the space. Y'all have done some machine learning or at least worked with different existing APIs. What are your thoughts on this question in terms of serverless machine learning for developers? Yeah, what's been your experience so far with this? And we can toss it over to Paul first because it looks like he's already unmuted, chomping at the bit.
Yeah, I got started with just APIs, just like Luca said, right? A few years ago, all the cloud providers were like, here's a shiny API and some free calls into it. So I was building apps that could do vision, like computer vision, and like chat bots that had language processing. And that really whet my appetite for what was possible, right? And so behind the scenes, just a gigantic amount of compute. And now, most recently, I've gotten into the Hugging Face community, which is amazing. If you all are not aware of Hugging Face, you need to go there and check it out. It's a total machine learning community. They host the models. And I've never done like from scratch, like with data, training a model, outputting a model, then using the model. So what I think is really exciting for people who are like serverless developers like we just can approach at the highest abstraction that we need to build what we want. And right now, it's, for me, it's more been about playing with it and seeing what the capabilities are, like all of the fancy image to or text to image generation and the different diffusion models that are available. And you know, setting it up is quite a bit. You know, when you even to get your local stuff running, I joke all the time, I have no idea how Python actually runs. So I just get a Colab space, which isn't technically like serverless because you have to pick a server, but it's very frictionless. It's like, give me one. And it like hooks up all the NVIDIA stuff, all behind the scenes. And so I just use Colab, you know, and until I'm ready to like dive deep into the statistics, you know, and I know SageMaker will be there when I'm ready for it.
No, absolutely. And I think this is a great point that you brought up, again, similar to Luca with the abstraction layer and starting from that. A lot of people don't have to go to writing their own models. And that's a really important note. I think, you know, I worked on a team in the past at a pretty large company, and we were doing computer inference. And there was, you know, you could potentially argue that we were spending way too much money actually trying to build it from scratch and doing all those little intricate things. Because I've looked at how the models are generated, and the 0.003 number, that if it goes off, now everything is run awry and no one knows what actually is happening when somebody just messed with it until it finally got that right setting. And so then we tried to modify and find ways around it. And then all of a sudden Google came in and just completely sweeped us. And so they somehow were able to do all sorts of magical stuff that we were running into issues with. And so I think it's really interesting, the idea that for someone that's just making an app where they're accepting user text and saying that out loud, there's existing APIs you can use for that. And it makes it really easy to iterate and kind of build these ideas out by leveraging that. With that, we toss over to Benoît. What's your thoughts on this, working in the space for quite a while?
Yeah, as I said earlier, I have zero experience with machine learning. So, but if I would start actually using it and learning from it, I would definitely start with serverless, because as we said earlier, it's just not easy to start with, but also it's a very cheap way to start actually using it, because as far as I can tell, as from what I learned in the few previous days that I actually have done some research of it, inference, which is the step that is the most useful to your use case, to your users, is also the most expensive. So if you can run it on serverless and reduce the cost of it and use a model that you download from Hugging Face or a pre-built model that you don't have to train, that you don't have to build yourself, it's not only fast, but it's cheap to actually run. So I would definitely start there.
Yeah, this is awesome. Yeah. And I appreciate you bringing this up, because, you know, you're being very humble by saying you don't know a lot about it, but then you brought up a point that I had clicking back in the back of my head a second ago, which is one thing that I was working on back then with the serverless machine learning workflows, this is like 2018, was actually loading it onto a Lambda function versus having to run these huge inference servers to basically run the model, have this really fast response time. And so instead of loading up these huge EC2 instances for our custom models, we were basically loading it onto the Lambda, having a huge cold start, but then every request after that was a bit faster, sub-second, to actually get the uploaded image, we get the result back, and then we can actually review the results of that. And it turns off and on based on usage. And so you're not running some huge bill, which we had massive bills around all of this. So I definitely want to throw that over to Luca, but first let's hear from Ro. Ro, what's your thoughts so far, serverless machine learning?
I think I'm on the same boat here as Benoît, in terms of usability and experience. I haven't really done anything significant, or I've not even tried out machine learning yet, but I've been taking a look at the recognition library. A couple of weeks from today, I'll try to see what I can pull up or write down with with that library. But so far, I don't have anything to share. Sorry, guys.
Oh, you're fine. There's multiple topics. So with that, I do want to circle back to that last piece, which is it worth it? Luca, Cyril, maybe Paul, you have an idea too. Is it worth it to load, if you are going to write your own model, is it worth it to run it on a Lambda like that? Obviously, there may be some slowness and things like that. Is it worth it in the development phase? Is it not worth it at all? What do you think about it?
Yeah, I've just done this a couple of days ago because we had a machine learning model for image memorability to detect how an image can stick in the mind of a person looking at it. And it is an evolution of a model presented by the MIT a couple of years ago. And we implemented that model, and we were running that model on the GPU, and it costed on a P3 2x large, it costed about 2,000 Ks per month. It was a huge amount. Then we decided to split the model and bring the lighter part of the model to CPU. And then we found out that it was an amazing speed up of the moving that part of the model to the CPU. And then we were able also to deploy that to Lambda, which has a cold start of about 30 seconds, which could be a lot if you think about that from a serverless perspective, but it is just the first time that you need to fire a new container, which can be easily overcome using provisioned concurrency. The result, bottom line, was that fact that now we were able to push that model on CPU and spend, say, $80 per month instead of 2,000 Ks per month. So definitely there is room for models on Lambda, even if Lambda still doesn't have GPU support, which I hope is coming. And it was announced a couple of years ago, say 2000 reInvent 2019, it was announced, but we are still not there. I'm confident it will come sooner or later. But still, we have there is room for deploying models to Lambda, especially now that we have OCI support, so we can package the model as we did. We can package the model within the Lambda, and we have also some alternatives to standard Python Lambda. I have been experimenting a lot using Rust and building machine learning models with Rust on Lambda, which can be super fast because we have a porting of some Python libraries such as pandas down to Rust, and that port is 16 times faster than the original pandas. And I've been able to train a customer churn prediction model on Rust and deploy that to Lambda, to the ARM version of the Lambda, which is super cheap.
Yeah, this is awesome. I think that hopefully lots of people end up watching the recording of this. We have about 7 people live, but that's really good information that you're sharing. And if you haven't wrote, I'm sure you've already written tons of articles being a serverless hero and all that, but wow, that's to see the breakdown there. Thank you for also giving the calculation with the EC2 instance from $2,000 to $80 a month, and faster speeds, and also giving some of the discrepancy, or not discrepancy, but the sort of downside, but not for everybody, that it could have a cold start initially of 30 seconds, which can be overcome with provision concurrency, which is all really good info. I think on that sort of topic that we're sort of still going on, Cyril, from your end, have you run like serverless machine learning workloads like this before? Do you have any sort of like feedback on it, or any things for people to look out for? What are your thoughts?
Yeah. Would the advantage of, like, I'll just take the example, for example, with the SageMaker endpoint, when you use the traditional SageMaker endpoint, not the SageMaker serverless inference, which was introduced last reInvent. I'm talking about the old SageMaker endpoint. You'll be talking about a decrease in cost of about 50 times decrease in cost. Yes, just with that simple fact that you chose to use the SageMaker serverless inference for your inferences, instead of just leaving the SageMaker endpoint, which is per hour. So that's just an example. And it's just a Lambda, which is put behind the inference, so it turns on and off. Just a Lambda, which you could put yourself if they are on your own, and you'll be doing the same thing. And then now you'll be having 10,000 simultaneous requests at the same time because of your Lambda advantage. And you can also scale easily because of that Lambda, whereas when it was just an endpoint, you were not having those two advantages. So it's really something we are looking up to. And I'll join Luca. We really need more improvement in terms of the training, because the problem is on the training with the fact that we need to be able to do that with GPUs. So we are now with the inference, but we really want to see more of the serverless going right back to the training so that we can be able to handle all the memory and size limitations. Yeah,
I love this, and I think one thing that's becoming clear hearing y'all talk is what's kind of cool to see is that when things were starting to transition towards serverless, let's say like 2017, like 2018, 2019, and obviously still at mass, there's a lot of, the majority of companies still are going to or are in the process of moving towards some workloads to serverless or a lot of workloads towards serverless. And the cost calculation front of reductions was always sort of like tricky and murky, because it's like the plane was sort of being built at the same time, and it was like we didn't have that high level metrics. It's really cool to see, hear this with machine learning now going serverless, and to have that sort of number that you gave out with the SageMaker 50 times savings, what Luca said, 16 times savings, this optimizations, and also whatever $2,000 to $80 is, scale that over a global company that's running stuff everywhere, and that's a huge number, that's being reduced. To kind of carry this on, anybody can jump in if you know or you have experience with it. When it comes to running serverless machine learning in production, is there additional things that are different? Is it good for test and development and not good for production, or can it work in both? And have y'all seen that, in your spaces?
Yeah, it helps because when you go serverless now, you would be, before you had lots of things you had to control, lots of moving parts, because you're trying to ensure you're in check with the infrastructure, you're in check with security, you're in check with so many things. But now imagine that you wrap that with your serverless framework, for example, and it's and you have your Bitbucket pipeline. It's just everything's your CI/CD. So you're just left with simple unit tests. As soon as you succeed on your unit tests, then you're good to go. You deploy again, you relaunch, you can just move. So it really helps. If not, you testing so many things, because the back end, you've entrusted it to the cloud, and they are doing most of that part. So you're just left with, okay, I just need to make sure I test my test well, my unit test, and then the rest, I trust that everything is fine. So it's a big reduction testing.
Okay. Yeah. So at least on Cyril's end, it seems like it is definitely possible to take this sort of stuff, move into production. Luca, it sounds like you're already sort of working on stuff actively with the serverless machine learning, as you were mentioning, with those optimizations. Is that stuff already in prod? Have you gotten any feedback around how it's actually running in a production environment?
Yeah, we moved that to production, and we had a number of deployments of different mixtures of services, using one of them using directly managed APIs, some other using managed APIs with custom models, and others using directly models through SageMaker. And finally, the last experiments were about packaging the model within the Lambda. They are all in production. We had great feedbacks about other development teams, because one thing that was super helpful to them is that packaging models within the Lambda, they were able to avoid changing their standard pipeline or their standard way of management of the application, or the development of the application. So they knew that the Lambda was triggered by an SQ or a kinesis stream. They knew that the Lambda was going to post back into a topic the results, and it was much easier to them. So if you are working in a team which is a serverless team, and you came from the AI or the machine learning team, and you need to work with them, something that could be considered is also the less friction that you have when you need to work with them. I've used SageMaker pipelines, which is a great tool, but the main problem is that it builds out a number of Python scripts that builds out pipelines and deploy pipelines, which is super great. But if you bring that code or that stuff to a Git repo and throw that Git repo to a serverless folk, he is going to tell you, okay, I don't know what to do with your code. Because the problem is that also managing such kind of pipeline has a learning curve that is not flat. Being able to stick back and to use AI through Lambda allows you to shift the load to something that usually your dev team is going to manage.
One thing I wanted to ask you, Luca and Cyril, have you ever looked at combining like the cloud inference along with like specialized local hardware? Like now that these TPUs are getting smaller and chipsets are, I fully believe that we'll have AI specific chipsets that will be able to run the model locally on your device. So like my laptop will have an AI chipset, your phone will have an AI chipset, and you'll be able to offload the inference part. But like the heavy training that goes on in the back will be done, somewhere else. Have you all tried that yet?
I haven't personally really, but I know things like Neo are meant for that. So where you have your inference are done on the devices, but like edge devices. So, but I haven't worked on that. Sorry.
I've done that. I've not done that directly, but my team did. They used Neo to compile computer vision models for video surveillance and to deploy them on AWS Panorama. I want to split the answer into parts. The first part is related to tools such as SageMaker Neo that can try to optimize your model to a very specific kind of tensor processor or AI chipset. And definitely, I agree with you, Paul. This is the direction. I think that we will have more and more co-processor either on your machine or at the edge or in the cloud that can offload the management of the AI part. And SageMaker Neo, which is built on an Apache open source project, is great doing that because it tries to compile. It supports a quite standard version of TensorRT, and it works well. On the other side, deploying the model, I think that there is a room for custom and specific deployments at the edge of models. And it is the case for specific hardware, specific AI hardware within a specific AI chipset, such as the Panorama or ADAL or the Intel Movidius or the Myriad. So now we have a couple of them that can be a solution for deployments on a specific hardware because we need to compute to process a lot of information, but we don't need to transfer that amount of information. Just think about computer vision for video surveillance. You need to detect whether or not a person is entering a danger zone, but on the cloud part, you just need some kind of reference of that information. At least you need the frame where a person entered that danger zone, not the whole video. So being able to process the video locally can lower the cost, can reduce the requirements on the network part, and also make your cloud infrastructure be able to scale up freely with less friction.
Totally. Yeah, I think specialized hardware is here. Like we know it's here. The neural cores inside of the iPhones. That's how it does all of the amazing things that it does. And I'm looking forward to when like the browser will start having access to these little AI cores, because it's totally coming. Totally.
Yeah, this is a great topic. And it's super cool. It definitely goes way past my expertise in terms of hardware stuff. And I'm glad that, Paul, you were able to ask that question, because it sounds like we got a really good segment from Luca there about going into it. I do want to, thinking about time, thinking about 3 topics, and we're sort of like, getting 30 minutes in here. And I think this is going to be a great topic, because not only is it about what is data ingestion, how to pick the right data ingestion architecture, but it's also a reminder that, at least on the project I was on, the machine learning part of actually modifying a model was like 5% or less of the work that we actually did. Everything else was how to get the data into like S3, the Lambda function supporting it, all this crazy background stuff of like testing and seeing if the model's performing, and the app that's actually utilizing it. And that's all related to almost everybody's skill set here. If you've ever built a serverless application, I would argue it's probably like the 90% of what's happening after the machine learning model is actually built. And so feel free, Cyril, Luca, if you disagree there, definitely jump in. We'd love to get a bunch of different opinions there. But yeah, on that note, let's go ahead and talk about what is data ingestion. I think y'all are probably the best people to present that argument there. So Luca, what do you think about this question here?
Yeah, data ingestion is something tricky because it requires you to be both on the cloud native and on the data management, data engineering side. So it's something with, in my opinion, I think that could be 70. So data ingestion, data management, and feature cleaning, feature extraction, data cleaning could be between 70 and 80% of a machine learning project. But I think that it could be 99% the reason why a machine learning project fails. I've scars about that. I can show you my scars about that, because the problem is that you have to plan for the right amount of scale. You can over-engineer the data ingestion process, which means that you are using a cannon to fire to a fly, and it means that you are overcomplicating your problem, and it is a problem. But on the other side, you can underestimate that. Just let me give you an example. A couple of years ago, it was 2019, I had to build a data ingestion structure for a customer that was processing, say, 150 million events per month, and that events were coming from their front end. We needed to process them, to clean that data, and to run a sentiment analysis algorithm on that data. It was super cool, but the problem was that we missed the point about the storage of that data. So we pushed that data into DynamoDB, which looked to us a great choice because it guarantees you a single-digit millisecond response. And it is great if you need to push the data into that. But the problem is that at some point, we needed to extract that data. And extracting that huge amount of data was something that required a lot of effort and reduced down to 0 our margin on that project. So data ingestion is something that can easily make your project derail because you have many options. You have many options for the tool, about the tools. You can choose between glue, you can push the data to Kinesis, you can use standard APIs, and so on and so forth. You have many options about storage that goes from S3 to, say, Feature Store, to DynamoDB and whatever. And you have many options about the tools. You can use Apache Airflow, you can use Glue, you can use Data Wrangler, and a number of tools. And having a complete understanding of what is the right tool for what is not easy.
Without injecting my own stuff, because I definitely have talking points after all the stuff you just said. I love the 99% fail based on that piece, which is I'll relay that back to my own experience after. But Cyril, what do you think on this similar sort of question here? Data ingestion, what is it? And yeah, if you want to answer or jump off any of the stuff that Luca just mentioned, definitely feel free to.
Yeah. No, Luca really, what he said is really pertinent, and I agree with you. 99%, I still agree on that, because it's a garbage in, garbage out. It has to do with you having the right data and being able to, because there are many possibilities. That's the problem with machine learning in general. You could do them in many ways. There are many models. Your data is different from mine is different from yours. So you need to, that's why we spend most of the time on the data collection, data cleaning, feature engineering. And then we might then to discover that data was not even good enough to solve that problem. Then you have to scrape it. You go again, look for more data. So it's really a very, very, very key process for us. And at times we are confused because the data could be real time. Would you be using Kinesis data stream? Will you want the near real time to talk about Firehose? Will it be batch? Will it be structured data, unstructured data? So at some point in time, there are so many moving parts. Will you be using MSK? Will you need to do some some kinetic data analytics off the fly real time on the data before pushing it to your Lambda to glue? Also, there's really lots of moving parts, and it has to do with the business, the data engineers, the data scientists, and there's some political decision at times behind it, and there's the who is right, who is wrong, and it's not generally the skill set of the machine learning engineer on the first place, because he spends most of his time studying all the different models, cat boost, ADA boost, XG boost, all the boosts and different namings, and only to discover that you don't even have the data to be able to use it to solve those use cases. So it's really, I support Luca 100% on that. It's really a real issue for us. And yeah, we really need to find a way for the machine learning engineers to go back to the data engineering side, walk through that, we can call it our own full stack, from collecting the data right up to delivering the model. If not, it's garbage in, garbage out.
Yeah, one thing that I would add is that in software we have architecture patterns, we have the software design patterns. On the other side, about data, we are still missing data patterns or something reusable concepts that we can apply to a variety of use cases.
Yeah, I wanted to jump in here with a use case that I had when I was playing around. We're comfortable with DynamoDB, and we love to do our single table designs. And so what do we shove in there? Like ultra long hashes and like duplicate data everywhere, right? Because that's what we're doing. We're making the single table design. Let's what is it, denormalize or normalize? Basically, like everything's just duplicated everywhere. So on a row, you've got hash ID, hash partition, hash key, hash, like all these things. And when you go to grab that information to feed it into Python, it's like you have to reparse out all those hashes. You have to reparse out everything. So one machine learning library I came across was querying data with just like normal questions, right? Like, how long is the Eiffel Tower? If you have a chunk of data that says tower, and then it's labeled like height, and it has a number. So I looked at this, I took all of my like blog posts, and they were just in like normal text, and then you get dumped into like a spreadsheet view. So then you have to write some more scripts to unspreadsheet it, and that's definitely where a ton of the work is, because I had to go in and take all these separate tables and cells and stuff and inject like Eiffel Tower is height, and then run it through the machine model, and then you can start querying through the interface like how tall is something. And that really showed me like that data cleanup process. And we have to think, oh, it's no longer consumed by Dynamo, because that's just like we rewrite it so that the machine can read through it, right? And so that was a real use case that I ran into. And yeah, data engineering is a thing for sure.
Yeah, I wanted to jump in on this. I had I wrote down the notes I got, maybe you can see it here, but everything before this line is all the data collection, cleaning, et cetera. And then you have like deployment, infrastructure as code, CI/CD. So it's like the stuff I had there is like, for instance, with computer inference, you know, where are the images coming from? So it's sourcing of data, quality of data, the actual, if I'm trying to have something that recognizes this bowl or different cups, I've got to have tons of different angles, lighting, et cetera. I have to do filtering on that. I might have to change the orientation to really try to trick up the model. And that's why where S3 came in, Lambda triggers to do resizing, to add different backgrounds, to swap backgrounds out, to make it grainy, all different things around that process. And all that is application code. So that's where I was looping it back with, you know, people that may be listening, that haven't worked and created models. It's a ton of work there to be able to write all that stuff. And it's a very easy pivot point for someone that's doing like web application development or mobile application development, because you know, you can still write Node.js lambdas and all that fun stuff, or build websites with Python. And then the cleaning part, so filters, shrinking, labeling, right? Like we were saying, we had entire teams of people that were taking different categories and they had to upload it in the correct spot. We had issues there that happened. We had issues with the upload size. Oh, wow, we're trying to flood S3 with gigabytes of data and it's just saying no, right? And so we have a whole, like, how do we break these things up so we can actually get it to the Lambda to then actually do the chopping up and actually getting it to the training part. Then you have to iterate on that model. You have to actually see what the result is. You have to do micro tweaks. You need an entire pipeline supporting all that stuff, which is also related to traditional application development. And then finally, finalizing it, IaC of all this stuff, CI/CD, deployment of it. And you have someone in the background who's always working on that next model that's going to be slightly better than the future one, but they have to reuse that entire pipeline of stuff. And so, yeah, I just wanted to re-say all that stuff because it's so interesting the way y'all presented all this information. Benoît, Ro, any thoughts on stuff that you talked about? Any things that you know is kind of piquing your interest or questions you want to ask, anything like that?
Yeah, first of all, one maybe stupid question, but when we talk about data ingestion, I think we're talking about training the models, right? So when we feed the data to actually train it to recognize something or learn something, basically. Did I get that right?
I will leave it to you.
Yeah. That's a tough question because I think that when you're ingesting data, you are storing your data for the future. So you can use that data to train your model, which is definitely one kind of usage that you have. But sometimes you just need to consolidate that data, to clean that data in order to fill that data into something that could be useful to other layers of your application. Think about the fact that nowadays, a lot of people are talking about customer data platform. Customer data platform is about building a unique view of customers. So if you have Luca, you have the same Luca that goes on your website, that goes within the stores and buys stuff at the local retailer store, that writes about you on the social networks and so on and so forth. But the problem is that you usually have different streams of data representing me. And you need to collect the data, you need to ingest that data and to build a single view of me in order to understand whether or not I'm going to buy your service or your product. Because maybe you want to send me a coupon, but you cannot send a coupon to every user that lands on your website. So you need to discriminate. But maybe I'm a loyal customer because I usually came into your physical retail store, but you don't know that. So you need to ingest that kind of data. You need to consolidate that data. And we are not doing machine learning of any kind in this phase. Upon that, you can build machine learning. Upon that, you can say, okay, I want to process that comments that you write on social networks and understand your sentiment, or maybe I want to analyze the streams of video, the video streams of Luca in the retail store, and then understand which kind of products he's going to pick up and then pull down after having seen them, and so on and so forth. But it's not something which is tightly related to machine learning. In my opinion, it is just a prerequisite, and it could be something that could make your life as a data scientist easier or harder, depending on the kind of data that you have managed. Let me give you an example. For that customer that I was talking before, we needed to rebuild the user section. We were collecting data about user movement, user interaction on the website, and then we needed to rebuild that to build the entity of the user section, which is something that required a huge of data engineering amount of work, because we needed to try to figure out, even using machine learning, whether or not an event was belonging to a specific section. On the other hand, the solution was much more simple than that. It was just adding a session ID attribute to the event sent to the backend. So just changing the kind of data that you ingested, we could change. You can change a lot of the bottom line and make the work easier or harder.
Yeah, totally makes sense. Thank you.
We'll flip it over to Ro. Ro, any thoughts?
Nah, I'll pass. I'll pass.
Okay. I know the second part of this question was what is the, how to pick the right data ingestion architecture. I think something that seems to have been made clear is there are some crossovers in how that pipeline runs and what services you mix and match, but there's also some level of it kind of depends on what you're trying to do. Would that be an accurate way of kind of summarizing that, Luca and Cyril, or is there a definitive, this is what you need to be using if you're doing machine learning with serverless, for instance, what services, et cetera?
Yeah, just like you said, it kind of depends on what you want to do with it. Yeah, because you will be talking, when it comes to big data, for example, the game changes. It's no longer the same velocity like you used to use with your SageMaker. You now start talking about EMR. You start talking about different things now. So, which means that all of that depends on what the nature of the data and what you want to do with it. So you'll be able to know SageMaker is off limit now. EMR comes in or EMR goes out. Yeah, so it's really depends on that.
Yeah, I totally agree with you. Also, because you need to find the right mixture between the tools that you know, because you cannot learn every tool that has been published that is available in the world. So you need to find the right mixture between the tools that you know, the tasks that you have to accomplish, and the kind of results that you need to produce. Just looking at me, I never approached Amazon Redshift, which I think that is a great tool for data warehousing. But my problem is that a few times that I had to face a number of problems that required Redshift, I decided to solve them differently, because the learning curve of Redshift was something that I was not able to afford at that time. It was a suboptimal choice, I know that, but it was the only option that I had. Maybe another person that is skilled in Redshift is not going to use, say, Athena or S3 or Feature Store, because she's going to say, okay, just let me push the data into Redshift and then pull that out with the right query. So it depends on the task that you need to accomplish. It depends also on the skills you have and the knowledge that you have or your team has.
Yeah, I think that's a great way to summarize that. We did have some comments on YouTube. We've got Jonathan DeGroot. I have no idea who this person is who asked this question here, but he said, what is the difference between machine learning versus deep learning versus AI? All these terms that are interchangeable, are they interchangeable? Are they not? I've got an opinion. I know that you two definitely have an opinion. Luca, do you want to kick it off? Then we can go round robin.
Yeah. There is a quite significant difference between them. Nowadays, everyone is talking about AI because everything that resembles some kind of intelligent machines is called AI. But AI is something quite specific, and throughout the history of AI, since the early beginning, say 70 years ago, it is something about making the machines able to implement the same processes that the human mind is trained to do. So AI is a broad field that has within different numbers of stuff, such as logic, inference logic, such as genetic algorithms, such as say support vector machines, and so on. So AI is almost every attempt in the human history to make some kind of intelligent machinery. With machine learning, which is a subset of AI, nowadays everyone is talking about machine learning because in the last, say, 10 years is something that moved a huge leap forward and provided a lot of results that are applied in a number of sectors. But machine learning is a subset of AI, and it is related to making machine able to improve with their experience. So the formal definition of machine learning is that from one iteration to the other, to the following one, you are increasing your performance thanks to the experience that you build up. So it's deeply about learning. And deep learning is still again a subset of machine learning, and it is a subset in which you use neural networks. And within neural networks, say, just to make long story short, you have the first layer, you have the last layers. The first layers is getting the data, the last layers is pushing the results, and in between you have a number of layers which are not directly connected to the input of the output of the networks. These layers are called hidden layers, and the depth of the neural network is the number of the layers that you have between. And so the name deep learning is related to the family of algorithms that uses neural networks and that have many deep neural network within that. But you can do machine learning. So when you're talking about XGBoost or something like that, or random forest, we are talking about machine learning and not necessarily about deep learning. You can achieve the same result with neural network, but you can also use a lot of libraries such as scikit-learn and the random forest implementation with no need for neural networks, which means that you don't need a GPU, which could be useful to you. And apart from machine learning, we could also consider genetic algorithms, we could also consider logics, inference, and so on. That could be, or expert systems, rule-based expert systems, that could be something that could fall into the environment of AI. So this is the difference. And I think that nowadays we are misleading the terms. We are making them interchangeable, but we are missing one important stuff, which is the fact that maybe I think that some of these fields that are not in the cooliness part of deep learning could be helpful to improve deep learning capabilities. So you can mix and match expert systems with neural networks to improve the performance of neural networks. And now we are approaching this.
Yeah, that was really, really very exhaustive and can clear difference. So if we have to simplify, AI would just be anything. Think of robotics. Think of some robots. Think of some arm opening and closing a door. Anything which is done by, let's just say, a machine. That's AI. It might need data to reinforce it or not. But then when that hand has to think, is this Ryan? Is this who is coming in before I open the door? Or I've been opening doors to this kind of people before and they have been causing havoc here. That's now machine learning, which means it's now trying to think. It's trying to use data like spam. It's trying to improve. Okay, this is bad email. This is good email. From time to time, it's learning. So that's machine learning. So it's a subset of AI. AI with data. Then in machine learning now, because we have the opportunity of having more data, lots of data now. Deep learning came out, which deep learning feeds off huge data. Deep learning performance increases as data increases, but machine learning has a limit. After a certain limit of data, amount of data, the machine learning is no longer performant. So deep learning comes into like do the complex tasks, which are like being able to recognize an object, being able to recognize a song, being able to complete the text, which is not like the normal structured data of tables that we in Excel, being able to look at, okay, how many customers are going to buy this month? Yeah, that's more machine learning with the structured data, but deep learning is more of like we are trying to mimic the human brain. That's why they talk about the neural network, the neurons, like the brain. The child learns how to walk, learns how to talk. So I mean, it's just like we are trying to do that, but then you've spoken a lot. It was really exhaustive, Luca, and I was just trying to break it down, maybe simpler.
Yeah, I think both of these were so cool to listen to. I know that one documentary I watched was AlphaGo. Have y'all seen that?
Yep.
So good, right? So good, and that definitely gets into what I'd imagine. There's as y'all mentioned, machine learning sounds like the method, right? It's like the method. There's like unsupervised, there's supervised. There's probably tons of other stuff. My brain is definitely not up to date on all that. And then there's also narrow AI, so like training for a specific task. So like playing chess or something. And then there's general AI, which obviously is probably way outside the scope of what we're talking about here, which is now able to do all things, learn everything. It's not trained on specific chess games. It can just take in, it has the basic components that we all have to then perceive all the information happening and then come to conclusions. And that part's still a gap there to getting that to that point. But it seems like, it sounds like we're making huge steps forward. One thing that I love hearing, the way that you circled that back there, Cyril, is the idea that we are learning about ourselves through the process of like trying to build out these systems. And wow, that's just, I don't want to get into simulation theory and all that stuff, but it's super cool stuff. And I'm sure y'all working in the space like y'all are doing actively, your brain's probably constantly thinking about stuff like that, which is so cool. Paul, Benoît, Ro, thoughts here. I think we might have one more question before we get to sort of wrapping on this panel today.
Yeah, I just want to say, like, as a dev, the things to really get into for machine learning is thinking about your regular process and your regular like day-to-day operations, and you're going to think, oh, I need to automate this. And then beyond that, it's like, well, how can I automate this so that it's intelligent, right? So that I don't have to specifically tell it all these different steps, right? It's like the jump from like imperative to declarative sort of styles. Machine learning is going to give you that flexibility to be more declarative. You want to say what the end state should be, and then the machine learning, the model that you build will help push your inputs into that end state for you.
Yeah, I just want to add that I have little knowledge about machine learning, but that's definitely something I would like to learn and use. I see so many use cases that you can use, so many things you can do with it. And I think I will definitely look into it a bit more in the following months or years. And again, thank you everyone, Cyril especially, and Luca, for the masterclass about machine learning. I definitely learned a lot today, and I will definitely apply this soon.
Yeah, like at least I've known the difference between AI, machine learning, deep learning. Those are topics that I'd actually paid a lot of attention to. But I mean, I think now I would like to maybe take a more broader look at it and try to see how I can apply it to some of the applications, my side projects that I'm doing and stuff like that. So thank you, Cyril and Luca, you guys. I think we need more time on this masterclass, because I think there's still a lot. I know these guys have a lot to say, but we're almost rounded up.
Yeah, exactly. I think some of the stuff that, for those listening, if you're thinking about it, you've already got an app. There is the machine learning that you can do, or just APIs that already exist through like recognition or other services for text recognition, speech recognition, image recognition, and labels that you can then use in your app. Usage of your apps, behavior of your apps, emotions of your customers, based on what they're interacting with, how they're feeling, how that affects things. Obviously, it gets into the dark side. There is definitely a much longer panel about the dark side of all these things that I just listed out. Shout out to our friends at Facebook and all that fun stuff. But yeah, if you're interested in it, I just want to reframe the whole thing, and I try to do that throughout this panel, is that if you already are working with building, cloud applications, you're doing software development, there is a huge part of what it takes to actually run machine learning things that plays straight into the skills you already have. Personally, and I'm saying that from experience, because I was not the one that was deciding what neural net or how many layers, as Luca was mentioning, or what the sophistication of our 0.0004 number and what we're doing with all that fun stuff. But I was helping in terms of how do we get all these gigabytes of images into S3? How do we trigger lambdas from that? How do we filter it? How do we flip it? How do we restore it? How do we monitor all these things? How do we get it ready for production? CI/CD pipelines, and all that plays into how we build everything else, from web applications to mobile applications and so on the cloud. And it's definitely accessible. So if Luca's company is hiring and there's people watching, maybe Luca, do you want to give a shout as we're coming to a close?
Yeah, we are looking for brave people wanting to exit their comfort zone and try something new. And so keep in touch with me and we can deep dive into the topic. And I think that we are still at day one of machine learning. We are still at the beginning. There are a lot of stuff, a lot of things coming out. I've seen NVIDIA conference last week. Half of the session gave me an headache because I couldn't figure out what they were talking about. And they were great sessions and great speakers. So we are still learning. I think that we have a lot of stuff to do. And hopefully we won't face another AI winter. And so the hype will stay high and we will push the boundaries of machine learning.
Love it. Cyril, do you want to give your final thoughts as we're coming to a close today?
Yeah, for me, I really want to encourage, because historically we used to be enemies. Those on the full stack, we used to look at them like, okay, you guys want to go that way, HTML. I don't like repeating myself, CSS, all of that. But then on the other side, we said, okay, we're maths kids. We want to go statistics with machine learning. Then we kept pointing fingers at each other. I've been on Quora discussions. It's always pointing against this guy, that guy. But then with serverless, we are now talking the same language. So I'm encouraging developers who have been full stack, who have been running away from the maths, to start with the APIs, start bringing those APIs in. Because, for example, just with Amplify, you add predictions. It's simple, one single line, and you're already into your machine learning. You already just Amplify, add predictions, one line. So it's what you already have that there. So I'm just encouraging all our developers, especially on the other side, to join us so that together with our synergy, the best of both worlds, we can be able to add some smart, put some intelligence to your apps, because the big four are already doing it. If you give me your e-commerce your app without some recommender system in it, it's like old school to me. So we just have to step up and adding some intelligence in all our apps we are doing, so that together we can be able to match what the customer expectation is on the ground.
Very well said. Okay, well, we had an extra topic that we were going to cover today. We are out of time because I think the other topics naturally kept flowing, which is great. It was AWS CDK, what you need to know. I think that we cover IaC in every panel. So if you want to hear about CDK, watch the last 3 probably. And I think we covered it extensively. And with that, this is our September panel on serverless machine learning. Thank you so much for our special guest here, Luca and Cyril, of course. Also Paul, Benoît, Ro. It was great having y'all as an audience. If you have additional questions, all of the Twitter @ are there on the screen, so definitely DM everybody with all your pressing questions. And with that, come to a close, and we will see y'all next month. So thanks again, everybody, and
thank you.
See you later.
Thank you.